All right, this is section 3.5, graphs of functions. On this video, we're going to focus on two different things. We're going to focus on even and odd functions, and then we're also really going to focus more so on transformations. Okay, so the first thing we're going to talk about is even and odd functions. I think we've talked a little bit about this before, but basically what we're going to do is we're going to plug negative x into our function. So this is going to be similar to what we've done 2 sections ago in terms of that x plus h stuff and going from there. Actually, that was just the last section, 3.4, but the same idea. So here we go. We're going to plug negative x into our function. We talked before, we've got to be really careful to use parentheses so that everything simplifies correctly. All right, negative x to the fourth, that is still x to the fourth. Negative x squared, that's still x squared, so the signs are going to stay the same there. And the 5 obviously doesn't have a variable. So if we go back to our even and odd functions, we see that if it stays the same, it's even. If every sign changes, then we know that it's an odd function. So we're going to look at this one. We're going to compare the original to our new one when we plugged in negative x, and we see that it is the same, which means this is an even function. All right, let's do the same thing for the next one. Plug in negative x. And when we go through and simplify, negative x to the fifth, that's negative x to the fifth. So that's going to become this negative 2x to the fifth. Negative x to the third is still a negative, so that sign is going to change. And then negative x times 4 is negative 4x. We're going to compare these two, and we notice that it went from positive to negative, negative to positive, positive to negative, which means this is an odd function. Now, you should notice, or you should start to notice, that you can sort of look at the exponents. Just be careful, because eventually we'll get to other functions that don't have exponents in quite the same way. Last one here, we're going to plug in negative x. Negative x to the third, that becomes negative x to the third. This guy stays as x squared. Compare these two. They're not the same functions, and all the signs did not change, so this is neither. It's not odd, it's not even, it's just neither. It's just a new function. Okay, so that's even and odd. Now, here's the big thing for this section, parent graphs and then turning into transformations. You must have these memorized. Okay, I understand that things are open notes, but you're going to be able to get through things so much quicker if you just know these parent graphs and know what it looks like. All right, so the first one is a quadratic. That's x squared. Okay, the vertex is at 0, 0. It's U-shaped, and to make the U-shape, you're going to go over 1, up 1, and then start back at the origin, and you're going to go over 2, up 4. Okay, now these are just those squareds, right? So 1 squared is 1, 2 squared is 4, 3 squared is 9. So you could keep going if you wanted to. It's got a mirror image. So now I'm able to put dots right there and right there. Again, make sure it's a U shape. I know it's a little tight in there, but it's not a V. Please go ahead and add these 5 bullet points to page 12 of your notes here. If you need to pause it, go ahead and do that. Square root function looks like the top of a C. So you'll see this is sort of opposite of what we just did. So instead of, we still go over 1, up 1, because the square root of 1 is 1. But this time, to get that 2 and the 4, we're going to take the square root of 4 and get 2. So we're going to go over 4 and up 2. There is no mirror image. So your graph just looks like that. Absolute value is V-shaped, start at the origin, and then the slope is just 1 all the way through, positive, negative, and there is mirror image. This one is a straight line, so this one is a V going both directions. Again, you need to make sure you need to have all three of those memorized so that if you see something, you're like, boom, absolute value, I know what it looks like. All right, horizontal flip. I don't think this is actually in your notes. I think I must have left it out. So go ahead and add this real quick note to your notes. If we have a negative in front of our whole function, it's going to flip the graph over the x-axis. So it's going to flip it up and down. Next thing, transformations. Okay, the first ones are just adding and subtracting things. Now, wherever the number is in terms of the parentheses with the function, that determines what happens. Okay, so first, up and down is a vertical shift, and that's if you're adding or subtracting something outside of the parentheses. So plus C, the graph is just going to be shifted up. Minus C, the graph is going to be shifted down. Now, horizontal shifts are left and right. Anything inside the parentheses, and you'll see as we go along, this shows up a bunch of times, we're going to think sort of like a backwards universe. So here, plus C, if we're graphing right and left, plus C usually means go to the right. But since it's inside of our parentheses, we're going to go backwards. We're actually going to move the entire graph left. Same thing, there's a minus C. Usually that's left, but since it's inside the parentheses, we're going to go right. All right, here's what we're going to do. First, our parent function, I'm going to graph this in black. So the parent function is an x squared. And there you go. Again, the faster and better we know these, the faster these problems will go. The next one. This plus 4 is outside the parentheses. So that tells us to move our entire graph up 4. So I'm literally just going to pick up each point and move it up 4. So there's the new kind of middle point. I'm going to pick up this point and move it up 4. This point, pick it up and move it up 4. And then we'll do the same thing on the other side. There's that transformation. Everything got moved up 4. The next one, this is inside the parentheses. So I know I'm going to move something 3. Usually a plus tells us to move it to the right when we're graphing, but because we're inside the parentheses, we're going to move it left. Now I'm going to go back to the parent function. I just kind of tried to save us some room on our graph. So everything here goes left 3. So that graph, that dot moves left 3. We'll take this next one, left 3, left 3. This guy, left 3. This last one, left 3. And there we go. Let's go ahead and let's change this one to a minus. So change this last one. All right, we're going to go through and we'll see a couple different things. We've got a 1 and we've got a 2. Okay, I usually start outside the parentheses because I think that's easiest. This one's going to go down 1. Now this is a minus 2. Usually we think that means go left, but because it's inside, that means go right. So I'm going to go for my parent function, 1, 2, and down 1. 1, 2, down 1. 1, 2, down 1. 1, 2, down 1. And then 1, 2, down 1. And there is our new transformation. All right, the next thing we'll talk about is our stretches. So vertical stretch, we're going to stretch it away from the x-axis. Okay, remember our x-axis is our horizontal one, so we're going to stretch it away. Think of like the Stretch Armstrong. It's an old toy, but basically everything gets pulled, stretched away from our axis if it's greater than 1. If it's less than 1, it's going to get squished. All right, so first of all, here's our parent function. It's absolute value. Now, when we look at this one, we see that it is less than 1. So we're going to squish it toward the x-axis. All right, so sort of a couple different ways you can think of this. Basically, we're taking half of every point. So I'll start right here in the middle. If I take half of 0, that stays right there. This guy is at 1, so if I take half of 1, it's at about a half. Kind of gets a mirror image. This guy's y value is 2. If I take half of 2, I'm at 1. Half of 2, I'm at 1. All right, now I know that each of these points through here, right, like this guy is 4, 4, so I might go use that one also. Same thing there. So we can squish those, take half of those, and get to be right there and right there. So the red line is our final answer. So again, that whole black parent graph, basically we just took something really heavy, really big, and we just sat it on top of it and squished it straight down. Parent function is a square root. So we're going to start here, 4, 2. Now this value 2, again, it's outside the parentheses, outside the function. So we know that we're going to compare it to our x-axis, and it's going to act like normal. So we're going to pull away from the x-axis. We're going to stretch it from the x-axis. Basically, we're going to double it. We're going to multiply everything by 2. So the y value here stays at 0. This y value is 1. I'm going to double it. I'm going to stretch it up to 2. This y value is 2. I'm going to stretch it up to 4. I'm going to add one other point. Let's see, the square root of 9 would be 3, so that's going to be right there. So then the square root of 9 up here now it's going to be 6. I think that just gives me a little bit better something to shoot for. So again, if you look at that red graph, we pulled it away from our x-axis. We stretched it from that horizontal axis. And then the last transformation we're going to talk about today is a horizontal stretch. Now again, this is where it's nice. Inside the parentheses, we still think backwards. So usually something bigger than 1 is a stretch. But because it's inside the parentheses, we're actually going to squish it. But this time it's going to be squished towards the y-axis. So it's going to be squished in towards the middle. Same thing here. Usually if it's between 0 and 1, it's a compression. But because it's inside the parentheses, we're going to stretch it away from our axis. So you're going to look, we're going to see really similar numbers here. Absolute value. Start off the same. All right, now here we go though. We have 1/2 and it's inside the parentheses, inside the function, right? So this is absolute value. So we have to think backwards. Now, we know that this one's going to be compared to the y-axis. Anything inside the parentheses, we're going to talk about moving left and right. So inside the parentheses, usually 1/2 means we would squish it, but this time we're going to pull away. We're going to stretch it. All right, now the middle point never moves. Okay, but this guy, right now we're going to stretch this graph all the way this way. We're going to, just take the right side and pull it away. Take the left side, pull it away. So in terms of the points, here's 1. Now again, 1/2, you have to sort of be careful here because what we end up doing is really using the reciprocal. So this is going to be by a factor of 2. So now 1, we're going to stretch it out twice. It's going to go right there. This is a value of 2. We're going to stretch it out and we're going to get to 4. So I'm comparing it to the y-axis, and I'm stretching out those x values. Now you will notice that this is really similar to before. So with transformations, there's actually a couple different ways to get the same answer. Sort of just something to keep in mind. We will not necessarily talk about this and deal with this a ton, but different ways to get the same type of thing. All right, then our last one, square root function. All right, value of 2 inside. So that tells us we're talking about the the y-axis, but this time it's actually going to be squished toward the y-axis. Because it's inside the function, we got to think backwards. Okay, so this guy doesn't move. This one gets squished. Again, we got to get reciprocal, so we actually have a factor of 1/2. Let's see, this is an x value of 4, so I'm going to squish it in half, and it's going to go right there. This is an x value of 9. I'm going to squish it in half and go 4.5. Sorry about that. Okay. And there's our function. So that is the end of 3.5 for now in terms of graphs of functions.